Alright folks, here we go. So I had a request to talk about long division and to do it in the context of a problem. So here's the problem we have, but let's review how we would do long division. So let's say I had 7 divided into 648. Well, 7 goes into 64, it doesn't go into 6, so 0 goes here, it doesn't go into it. But how many times does it go into 64? It goes into it 9 times. And so I do 9 times 7, get my 63. So I have 1 left over. It goes into it 2 times, multiply it back, 14. I have a remainder of 4. So I have a remainder of 4 divided by 7. I have the remainder divided by my denominator. So here we go. So let's go into this one. So I've got x squared. I just look at my front term, and I'm going to see how many times it goes into that one. It goes into it x times. If I do x cubed divided by x squared, I get x. Line it up with that power, because that is x to the first, and I have x to the first here. So I'm going to multiply it back, and I get x cubed. What's my next term? It's x times x, which is x squared. And then I have minus 2 times x, so it's minus 2x. Now, here is the one tricky thing. We did it over here, we just didn't really show it. You subtract, and this is what you have left over. So I need to subtract. Well, when I subtract, the issue you're going to have is with negative signs. So x cubed minus x cubed, that's an easy one. But 0x squared, which is nothing, minus x squared. And then here I have negative x. This becomes, that negative and that negative become plus. So I have plus 2x of plus 2x minus x of plus x. Carry down my 3. And I see how many times does, so now my next step, how many times does x squared go into negative x squared? Goes into it negative 1 times. So I multiply that back through, I get negative x squared minus x plus 2. Now, say it yourself, what do I do next? I subtract. And so as I subtract here, I get 0 here. Let's go back to black, sorry. I get positive 2x, because I have a positive x plus x, so positive 2x. And then I get plus 1. So that's my remainder. And what did we do with our remainder before? We took it and divided by my denominator, the thing I was dividing into it. So I have plus 2x plus 1 all over x squared plus 1x minus 2. So if I'm now thinking integrals, instead of taking the integral of x cubed minus x plus 3 divided by x squared plus x minus 2, which I could not do a u substitution for, so it is impossible. I couldn't do it. Well, what I did is I just rewrote it as x minus 1 plus 2x plus 1 over x squared plus x minus 2. This right here should scream u substitution. If you look at the top, 2x is the derivative of x squared. 1 is the derivative of x. So now I can separate this out and do that integral separate. So really you have the integral of x minus 1 dx plus the integral of 2x plus 1 all over x squared plus x minus 2 dx. Alright, let's do another one. I've got another one queued up, so let me get that ready. Welcome back. I realize that wasn't a very long wait for you. For me it was. So here we go. X squared. So this is number 34 in section 8.5. How many times does x squared go into this? It goes into it 2x times. So I'm going to put that, line that up with that one. Notice how I've been doing placeholders. On the last problem I did too. And so it just keeps things tidy. So go multiply this back. I get 2x cubed. Multiply it to the next one, I get negative 2x squared. Multiply to the next one, I get 0. Remember, subtract. And so I get negative 3x squared plus 4x. Next step, carry down the negative 4, excuse me. And you look at how many times does x squared go into negative 3x squared. It goes into it negative 3 times. So multiply it back through, negative 3x squared plus 3x plus 0. Remember, subtract. This is the biggest mistake I've seen, is this step right here. Is we'll think add and not subtract. All right, so like I was saying, that is the biggest mistake I see. So you subtract that off, you get x minus 4. You're done. Leave it. This is your remainder. So add your remainder divided by x squared minus x plus 0. So you now have the integral of 2x minus 3 dx plus the integral of x minus 4 all over x squared minus x dx. Now, you don't have a simple u substitution here, so you can't do that. So I'm just gonna focus on this. So you can do that. So we're leaving that out. So I'm just looking between here and here. I'm going to divide that into each of them. So I have x divided by x squared minus x dx minus the integral of 4 over x squared minus x dx. First one here, if you factor, I've got 1 divided by x minus 1. The other guy, it's not looking as good, right? So we got to get a little bit creative with this one on the right. So you've now created an even more exciting thing to deal with, is because this, if you look at your denominator, you have 2 parts to it. And so now you could say, well, a divided by x plus b divided by x minus 1 equals 4 divided by x times x minus 1. And so now you get to have fun, right? So you got a times x minus 1 plus b times x equals 4. So you do your 2 situations. When x equals 0, negative a equals 4. And when x equals 1, b equals 4. And so you can use that to your advantage. So a equals negative 4 and b equals 4. So what this becomes is so I get a, which is negative 4 divided by x plus 4 divided by x minus 1. There you go. And you're going to do dx on that. And so you have a lot of steps, and we still have this from the beginning. So nice and complex, but hopefully you're seeing the strategy for long division. And then I think to keep in mind is you then at the end split everything up and look at it individually, because as you think here, you've got your 2x doable, right? When you get your 1 over x minus 1, that's a natural log. When you get this, you're going to be doing partial fractions. There's a reason why this is the end of chapter 8, after you've gotten better and better at working with integrals. Yeah, these are all really good problems. Make sure you go through all the odd ones that we suggest to do, because that's an excellent way to review. So, all right, thanks for tuning in. Have a good one.